So let's discuss about the Bernoulli's principle. Bernoulli's principle means it's a sum of kinetic energy per volume, potential energy per volume, pressure energy per volume is equal to a constant. What is the kinetic energy per volume? We have already discussed that. That is equal to half into rho v square. Plus what is the potential energy per volume? That is equal to rho gh. Plus what is the pressure energy per volume? That is equal to P, which is equal to a constant. So this is the Bernoulli's principle is talking about. In the diagram, there are two regions we are considering here. This is the first region and this is the second region. In the first region, area is more. We can look at the picture. The area is more. Say it as area is equal to A1. And in the second region, the area is now reduced. Say it as area is equal to A2. Once again, the liquid is flowing through the first area. Say it as the V1. And the liquid which is flowing through the second area, it is equal to V2. As we already learned the equation of continuity, A1 V1 is equal to A2 V2. Here A1 is greater than A2. Definitely then V2 will be greater than V1. We have already discussed about the equation of continuity concept. Now you can see here the pipe is kept in such a way that there is a height difference from the ground. So first region is at a height of h1 and the second region slightly above the first one. So say it as its height is equal to h2. Now we already discussed in equation of continuity, we are taking the time interval, we are considering the time interval of the fluid flow is taken as the same time interval delta t. Here also we are taking the same time interval delta t. So in the same time interval, how much liquid will flow through this one? We can write the distance traveled by the fluid in the same time interval. In the first region, we can write here velocity v1 into delta t. Velocity is equal to distance by time. So distance is equal to velocity into time. Same formula. Same way, the distance traveled in the second region, the fluid is traveling here a distance of v2 into delta t. This is the one we have already learned in the equation of continuity. So when the liquid is flowing from bottom to the top, if I say the pressure at the bottom is P1 and the pressure at the top is P2, the pressure at the bottom will be greater than at the top. So one conclusion we can make here, pressure P1 will be greater than P2, then only the liquid will flow from high pressure to low pressure. Okay. Now let's apply the Bernoulli's principle. For that first case we are discussing about what is the change in kinetic energy of the fluid. So first one we are discussing about change in kinetic energy of fluid. So in this case the velocity v2 is larger, so definitely we can say that kinetic energy at the second region will be greater than the first region. So what is the change in kinetic energy? Half mv2 square minus half mv1 square. Why I have written the here m alone, not the m1 m2? The amount of liquid is flowing will be same using conservation of mass principle, right? So we can write the formula here, half into m into, can be taken as a common, then you can write the v2 square minus v1 square. That is, once again we can write here half into, what is a mass? We have already written the mass is equal to density into volume, right? Density into volume into v2 square minus v1 square. So what is the density? Density means density of the liquid which is flowing through the pipe. So we can write here half into rho into what is the volume? Volume is equal to area into distance covered. So area into distance covered in means what we can write now? A1 into distance is equal to what? V1 delta T. This is the distance it is traveling, no? Area into distance. So A1 V1 delta T. So we can write here volume is equal to A1 V1 delta T. Maybe you can write A2 V2 delta T, no problem. Why? Because A1 V1 equal to A2 V2, no. So you can either write A1 V1 delta T or you can write A2 V2 delta T. So let's write here A1 V1 delta T. So rho into volume. Hope it is clear. Rho into volume into V2 square minus V1 square. So let's write this is the equation number 1. Let's write this is equation number 1. So change in kinetic energy of the fluid we got. Now let's calculate what is the change in potential energy. Change in potential energy. Look at the diagram here. Height h2 will be greater than h1. So which potential energy will be greater? mgh2 will be greater than mgh1. So what is the change in potential energy? mgh2 minus mgh1 can be written as mg can be taken as a common, then h2 minus h1. What is the mass? How much amount of liquid is now flowing? Mass m is equal to density into volume. That is equal to density into what is a volume? Look at the first case here. In the first region we can take it as volume is equal to area into distance covered by the liquid in the time interval delta t. So rho into area we have written as A1 into what is the distance it traveled here? Distance it traveled here V1 delta T. So density into volume, that is the mass. Now you substitute this value here in the previous equation. For mass we can write here density into A1 into V1 into delta T into G into H2 minus H1. This is the equation number 2, change in potential energy. What is the net work done on the fluid? The net work done is equal to work done on the fluid. Work done on the fluid at first region, that is this one, first region, minus work done on the fluid at second region. This is the second region where the area is very less. Okay, so what is the work done formula? We already know the work done formula is equal to pressure into volume, right? So we can write here pressure P1, first area, the pressure is equal to P1, P1 into V1 minus P2 into V2. V is the volume, V1 and V2 are the volumes. So we can substitute the value here, P1 into what is a V1? V1 we can write here A1 V1 delta T, A1 V1 delta T, right? It's a volume in the first region minus P2 into A2 V2 delta T. Okay, so what is this equation we can write here? If you take the common thing outside, you see this one, we have already proved here A1 V1 is equal to A2 V2 according to which one? The equation of continuity. By using equation of continuity, A1 V1 equal to A2 V2, therefore we can write here P1 A1 V1 delta T minus P2 A1 V1 delta T. A1 V1 delta T itself, because both are same. So now you can write here A1 V1 delta T. If you take it outside, we will be getting P1 minus P2, equation number 3. Okay, now you apply the conservation of energy. Conservation of energy means the net work done is equal to, we can write here the net work done is equal to change in kinetic energy plus change in potential energy. What is the net work done? Equation number 3. So we can write here A1 V1 delta T into P1 minus P2 equal to, what is the change in kinetic energy? Half into A1 V1 delta T into rho V2 square minus V1 square, alright, plus what is the change in potential energy? The change in potential energy is equal to A1 V1 delta T into rho into G H2 minus H1. You look at this equation, A1 V1 delta T, A1 V1 delta T, A1 V1 delta T cancel. So what is the final equation we are getting? The P1 minus P2 equal to half into rho into V2 square minus V1 square plus rho G H2 minus H1. If you take all the first term into one side, you will be getting the P1 plus half into rho V1 square plus rho G H1 is equal to P2 plus half into rho V2 square plus rho G H2. That means, hence we proved the Bernoulli's principle. What is the Bernoulli's principle? Pressure energy per volume, kinetic energy per volume, potential energy per volume, all is sum is equal to constant. Hope it is clear.